I'm Just Nicely.
And I'm Jacob Yaris.
And the paper that we picked is the effect of caffeine ingestion on 1RM muscular strength. Okay, so studies have demonstrated the aerogenic ability of caffeine for endurance exercise, and this includes the ability to enhance physical performance, stamina, or recovery. So within the paper's introduction, it talked about two different studies that assessed acute caffeine ingestion. The first study went over a cycle ergometer. There were 9 men and 9 women that completed the study, and they went at 80% of their VO2 max. There were 2 separate conditions. The first group was subjected to 330 milligrams of caffeine, and the other was given a placebo. And then after the study was completed, the group that took the caffeine, they went 20% longer than those with the placebo. And then the second study was over a 2-hour cycling session. Again, there were 2 groups. One group was given 250 milligrams of caffeine, and the other was given a placebo. And after the completion of this study, it was a 7.4% difference with the first group given caffeine that went longer. So the potential of caffeine to enhance dynamic muscular strength and endurance has received less attention versus aerobic activity. So again, there's only 2 studies that are known of that affect resistance training after taking caffeine. So the first study was demonstrated with 1RM bench press and leg press, and the second study was over muscular endurance. So the first study, they used a caffeine supplement, and then they also used a placebo. And the results of that study, there was only a difference seen in the 1RM bench press, and there was no significant result for the leg press. And then the second study, one group was given 4 milligrams of caffeine per kg and fahedrin. And both of these groups, there was no effect seen in either one. So, continuing on with the introduction, evidence supporting caffeine ingestion to enhance muscular strength and endurance are unclear, so more research is required. So the mechanism by which caffeine exerts the aerogenic effects are unresolved. So it is believed that the glycogen sparring and greater fat utilization explains the enhanced performance, but there is a study that shows the aerogenic effects of caffeine in the absence of lipolysis. So the introduction also talks about caffeine ingestion and the effects that it has on the human body. So it reduces the sensation of pain induced by exercise. It enhances excitation contraction coupling, and it also stimulates the central nervous system. And then the overall goal of the study was to examine the efficacy of pre-exercise caffeine ingestion during maximal strength and endurance testing. So the primary aims of this study were twofold. The first objective of this study was to examine the effect of the acute ingestion of caffeine on 1RM performance in individuals familiar with resistance training. So the dose that was given to the participants was 6 milligrams per kg body weight. And then the second objective of this study was to examine if muscular endurance was altered with caffeine ingestion. So it was hypothesized that compared to the placebo, caffeine will not affect 1RM performance, yet muscular endurance will be significantly enhanced with caffeine ingestion. So the participants for this study, 22 resistance-trained men were chosen. Women were excluded from participation due to data showing that menstrual cycles or oral contraceptives may alter clearance of caffeine. So the demographic data is described in Table 1. The mean age for the subjects was 23.4. The mean height was 1.78 meters. The mean mass was 82.5 kg. And then the mean caffeine intake milligrams per day was 110.5. And then caffeine intake measured by days per week was 4.4.
Oh, so now for the methods. The design, it was a double-blind crossover, which means that the technicians and the participants were unaware of which group they were in. And there were two groups, the caffeine group and the placebo group, and these trials were separated by a week. For monitoring diet and exercise, there were a comprehensive list of items containing caffeine that were provided, and it was asked that they refrain from caffeine intake 48 hours prior to testing, and then abstain from intense exercise 24 hours prior to the assessment. Now for the treatment ingestion, pharmaceutical grade caffeine was used, which was 6 milligrams per kg of body weight, or the placebo group, which was dimethylcellulose, and those were provided to participants in capsules. They were both ingested 1 hour prior to the exercise, and then 7 days later, participants ingested the other treatment and repeated the same exercise protocol.
So pre-test measures were also a part of the method. So 1 hour after the capsule was ingested, the participants' height, weight, and percent body fat were assessed. The percent body fat was measured using a sum of a 3 skin fold, which was taken from the abdomen, thigh, and the chest. And then heart rate was monitored via a heart rate monitor, and BP was taken manually.
So now for the exercise protocol, they started off with a 5 stationary bike warm-up. Their heart rate and blood pressure were collected at minute 4 of that warm-up, and then a barbell bench press warm-up, which included 12 to 15 reps at a workload of up to 61 kilograms. And then there were 2 minutes of rest between the sets, and then the 1 rep max was determined in 3 to 6 sets. So after the determination of the 1 rep max, 60% of the 1 rep max was then placed on the bar, and then participants completed repetitions of failure, which measures muscular endurance. And then while those tests were happening, heart rate, blood pressure, and RPE rating were recorded within 5 seconds of the final rep. And then 2 to 3 minutes later, participants leg press at a 45-degree plate loaded sled following the same protocol as the 1 rep max. 1 week later, then the participants repeated the same protocol, but flipped the treatment. So if you were in a caffeine group, then you took the placebo the next week, and vice versa. And then after the second trial, they filled out an inventory that took measure of the side effects and the symptoms to see if they could identify which trial was the caffeine trial. And overall, the entire experiment over the 2 trials took approximately 45 minutes.
So the statistical analysis was used, and SPSS was used, and an ANOVA was used. The data was reported as mean plus or minus standard deviation. So for the ANOVA assessment, it examined the differences in muscular strength and endurance, and then it also examined the differences between RPE between the caffeine and placebo groups. And then also a 2x2 analysis of variance was used, and this examined the differences in cardiovascular variables such as heart rate and blood pressure between the caffeine and placebo groups. And then the statistical significance was established as the p-value less than 0.05.
So now for the results, we'll start with the 1 rep max data. So the multivariate analysis, or ANOVA, indicated that there was no relationship between caffeine intake and muscular strength and endurance when compared to the placebo group. And the same was found for leg muscular strength and endurance when compared to the placebo group. 12 participants benched 3 kilograms or more in the caffeine group, but we saw 5 participants lifted more than that in the placebo group. Then 11 participants pressed at least 10 kilograms more in the caffeine group, and then we saw 8 participants press more in the placebo group. So we see a lot of contradiction in the results. Now, for the assessment of muscular endurance and total weight lifted, you see the table over there. The caffeine group bench pressed about 116 pounds on average, while the placebo group did 114, or about 115 on average. And the same was seen for leg presses. They pressed 410 kilograms versus 394 kilograms, so not much difference in those numbers. And then for the endurance portion of it, the number of reps for the caffeine group was 20, while the placebo group was 18, so there's not a lot of difference there. And the same thing goes for the leg press. There was 24 reps on average versus 23, so you don't really see enough difference in the data to say that there's a significant difference between caffeine and placebo groups. And then for the final portion of the results, they examined the side effects of caffeine, and 60% of participants saw a normal rise in heart rate and blood pressure during the warm-up period. So you see in the graphs above, in the caffeine group, you saw a significant rise in heart rate, as well as the placebo group. And the same thing goes for blood pressure. You saw a rise when compared to pre-exercise.
So the data supported the hypothesis of the 1RM bench press and leg press, that they were unchanged with the dose of caffeine. And then the number of repetitions at a submaximal intensity and total weight lifted were not different than the caffeine versus the placebo. So one of the hypotheses was accepted and the other one was denied. And then there was no difference in any parameter of muscular endurance that was noted between the two treatments, and that was likely due to the large variability in the responses that were reported. And then findings suggest that caffeine does not alter the performance, and that the acute caffeine ingestion has zero effect on the bench press, but it has a slight influence on the endurance. So differences in training status could explain these discrepancies. It is speculated that caffeine may have a greater effect on those that are more resistance trained. Familiarity also goes into this. Most participants were more familiar with the barbell bench press and not the leg press, so their results were lower than that if someone were more familiar with this. And then some subjects lifted more weight with caffeine, while others lifted more with placebo, while some were about the same. So there was no clean-cut answer on if caffeine had a higher influence on the participants. And then there was large variability between body mass and caffeine. So it is suggested in future research that the technicians find subjects that are caffeine naive and are more closer in body weight.
So now for the conclusion. Overall, it was found that the 6 milligrams per kilogram of body weight of caffeine taken 1 hour before exercise has no effect on any sort of maximal or endurance performance. But it was found that caffeine actually helped endurance by about 12%, which is not a lot, but it's seen as a significant result in this case. And then for future research, they would then ask, does acute caffeine intake have an effect on it instead of taking it 1 hour before?
And then also it is suggested that a larger group would be used in the recruiting process to see if more people would show a bigger influence. And then future investigation is warranted to see if training specificity plays a role in it. And then also there was a limitation to the study and the inability to measure if the caffeine was ingested because they weren't able to control the levels of catecholamine to see if everything was digested how it should have been. And here are our references.
Thank you.